Hello students, I am Raushan with you. Monday and Tuesday I was not able to continue the physics for you because I was participating in the system of Gurukul. I founded Bharati Institute of Administration. You can say Bharati Prasasnik Sansthan. From the 29th September, I am starting a new batch for the UPSC to become IAS, IPS and many class 1 officers of the Government of India. So today we discuss about the concept of force, their application as momentum and impulse. In the last class we studied about the force, momentum and impulse, second law of motion. Today first we discuss about the third law of motion, and after we go to the practice of the application of this chapter. Third law of motion. What it tells? What is the foundation of this law? What is the concept of this law? In a interaction of bodies, first body apply force on second and second body apply force on first. In opposite direction. In the opposite direction. You can take two bodies here. Body 1, body 2 interacting together, come in contact together. So first one, apply force on second body. Second also apply force on the first body. So what is the nature of this force? You can write here. Suppose one apply force on second body. So this is direction of force on body 2 by the 1. Again, to apply force in this direction. So this is what? Force on 1 by 2. I am writing here force on 1. What is applying by body 2? Again there is force on 2 by the 1. So you can say direction is what? Opposite in this case. And you can also write force of on 2 by the 1 is equal to force on 1 by 2, and this negative sign indicates about the direction. Again you can say this is the force of action, and this is what? Force of reaction. And this negative sign indicate opposite direction of force. This is what? Third law of motion. So if you push a spring, what will happen? A spring contract or expand. So I am applying force on the spring. A spring also apply reaction force on my body, my hand. So that is what? Force of action and force of reaction. Again, I am telling you about my birth, about your birth on the earth. This is the earth, and there is a bed or table. There is a table. And my body is placed on the surface of the earth. There is iron on this page, on this table. This is the table. On the table, I am here after the birth. This is a body. Body is I am here. You are here on this table after the birth. So this is the surface of the table. And earth is applying force. On the center of gravity. This point is what called? This point is called center of mass, you can say. And your center of mass is the navel. That is called nabi also in the Hindi. So navel of me bear total mass of the body. Total mass of the body of this structure lies in the center of this body. That is called center of mass. So on the center of mass, earth apply force of action, and this force of action is what? mg, mass into acceleration. G is the acceleration applied by the earth. So this is also called what? Weight. You know, mg is what? Weight. This is also called what? Force of action applied by the earth on my body, on the navel, on the center of mass. And when action takes place here by the gravity, by the center of the earth, this direction is what? Direction is towards center of the earth. Center of the earth. So I am making it clear. You are in the 10th floor of a building, of a mall. So mg is where acting. You always tell that mg is acting towards the center of the earth. I am on the -2 ground floor, उसके बाद 2 floor नीचे, below the ground. I am in the building. So what is the direction of the mg or action force towards the center of the earth? If you speak that, if you are in the 10th floor, it is force acting downward. A person in the 2nd floor below the ground, it also take that force of action is acting downward. There is what? Confusion there in the calculation. So always consider that force of action acted by the earth, applied by the earth, that is weight, go towards the center of the earth. Now when earth apply center action of force, body apply normal reaction force. Normal reaction force. So what is normal? Normal means on this table surface, this normal force is acting how much angle? 90-degree angle. This is the surface. This is the surface of the table. This is the body. There is force of action mg. There is force of normal reaction n. So this makes how much angle? This makes right angle from the surface. Since it make right angle, so right is also called what? Normal to the surface. So this is what? Normal reaction force. So two forces are acting here. One is action, second is what? Reaction. Reaction force. So I am writing here this mg is acting toward the center of the earth. So mg is force of action and normal reaction opposite to the action. So this is action, this is reaction. Again you can write mg plus n is equal to what? 0. So what it indicates? Sum of these forces are 0. It means net force is what? 0. When net force on the body is 0, it means it is it is state of equilibrium condition. Equilibrium condition of the body. See on the my body. My body has force of action mg. Reaction is upward at the right angle of the floor of the classroom. So action and reaction is 0. It means net force on the body is 0. That is why I could not fall down the earth. I could not move in the sky in the upward direction. So I am able to maintain the system of what? Equilibrium. Again, some force of air is acting my this part. Some force of electric is acting my this part. Many forces are acting on the my body. Friction force is also acting between the surface of the classroom and the my foot. So many forces are maintaining what? Net force is what? 0. Sum of all the forces was 0. That is what called, this is the condition of equilibrium. So I am telling about the third law. When two bodies and bodies are at the rest, I am not taking, not considering, not discussing about the any motion of the body. So when motion takes place, you can ask a question. So sum of all the forces are what? 0. That is, you know, condition of equilibrium. In this condition, we tell that there is balanced force. When balanced force is acting on the body, 2 bodies, 3 bodies, 5 bodies, and all forces are balanced, then there is no motion. So when motion takes place, we study for that balanced and unbalanced forces. I discussed you that this is my hand. I put here a duster. So mg force is applied by this duster on my hand, basically towards the center of the gravity, and normal reaction acts at right angle of the duster. Right angle of the duster. So this is what reaction force. So this duster does not go downward. My hand also not go downward and not duster upward. So this is condition of what? Balanced force. Again I am making here. This is my hand, this is the duster. So on the center of mass, what is applied here? There is applied force of action mg, weight, force of action by the earth, and there is what? Force of reaction. I am writing here N, normal reaction. Making angle how much from the surface? From the hand it makes what? 90 degree angle. So again, this is what? Force of reaction. And when mg opposite to normal reaction, mg plus n is what? 0. F net is what? 0. What happens here? No motion. If body is no motion, then what is acceleration? Acceleration is what? 0. No acceleration is there. So this is called what? Balanced force. This is called what? Balanced force. I studied it. Again, I keep a body. This is a ball. This ball applying on the center of mass force mg. So here is mg, here is mg, here is mg. Up to the earth, a ball come. Mg acts. Mg acts. So always there is what? Motion of this body. So motion takes place. Motion takes place of the body. No reaction force is acting. No friction force of the air is there. So mg is very large and air friction is very small. No friction of the air. So in this case, when body is in the motion, ball in the motion, acceleration is not 0. So there is acceleration exists. Or you know, this A is equal to what? Acceleration of the earth. In this case, mg is what? Here mg is basically unbalanced force. Unbalanced force due to mg or force of action. There is no reaction. So unbalanced forces cause motion of the body. If you apply force on the car, you are standing here and car is in motion. So you applied what? Unbalanced force. That is why car will go in the motion. There is bike, there is a scooter. Apply force on that. So you are not in motion. Your applied force is used to motion of the scooter, of the bike. Now we see about the applications. Applications in or you think? What you are thinking? First, there is a wall. From this wall, a ball strike. Ball strike, and this ball is reflected by the same velocity. Same velocity. Strike, then reflected. So, what is total momentum? You have to find out momentum. Let this is suppose when ball strike here, this is x-axis, and this is what? The wall is what? Y-axis. It strike making angle theta. Ball of certain mass, certain velocity, strike the wall and reflected back the same angle. Angle is same. You consider, you think. So there is what? Mass into velocity is momentum. So you can say momentum of striking in the x-axis. This is P cos theta. This is what? P sin theta. Again, when ball reflect in this axis x, there is again what? P cos theta. In the y-axis or y-dash axis, negative. This is again P sin theta. See here, P sin theta value. P is equal to what? P is equal to mass into velocity. It means this is momentum. So their momentum is positive, their momentum is negative. This is positive y-axis, this is negative y-axis. And again, when body strike on the origin, come back to the same position. So what is the condition? In the y-axis, this and this are cancelled out. Suppose this is momentum 10 kilogram per meter second. Then this is plus, this is minus. This is plus 10, this is minus 10. They cancel out. But total momentum is what? Total momentum is, you know, mv minus mu. Final minus initial. This is what? This is P cos theta and minus P cos theta. It goes to positive, it goes to negative. So this is again negative P cos theta. This becomes what? This becomes 2P cos theta. This one goes positive, this one goes negative. This becomes what? 2P cos theta. This is the value of the total momentum. Second application. A machine gun fires a bullet of mass 40 gram with velocity is 1200 meter per second. A person find recoil force of the gun is 144 Newton. How many bullets are fired per second? This is the general application, usual application in the life. Consider it is number of bullets fired in 1 second. Again, there is bullet fired, force is also there, and you know, impulse is what? Impulse is average force into time. So impulse is what? Also change in momentum. This is change in momentum. Change in momentum is equal to average force into time. This is equal to what? mv minus mu, change in momentum, and for the n number of bullets multiply with n. This is equal to average force. You have 144 Newton. Time is what? 1 second. This is n into mass is common. Final velocity is 1200 meter per second. Initially 0 is equal to 144. Mass is how much? Mass is there n into 40 gram upon 1000 gram into 1200 is equal to 144 2 2 0 0 क्या हो जाएगा n is equal to 144 upon 48. This gives 10 bullets per second. So this is the condition. You can think, you can imagine, and go to the answer. Third application. A rubber ball every application is based on previous year IIT, NEET and HC Burma book. So a rubber ball of mass 50 gram is fall from height 1 meter on the ground. Which remain in contact point 1 second. And rebound height of 0.5 meter. Calculate average force. Find out what is the average force on the ball. So in the previous class I told you, read the questions 3 times. What is given, what is have to calculate, and what formula you apply, and think for the event, think for the foundation. For the ball, go to the ground. And actual height is here. Pitch here 1 meter coming to the ground. it remain in contact for the time 0.01 second. It is given. This ball come back half of the height with the initial velocity u. Again, final velocity becomes here what? 0. Here ball is in the initial velocity, here initial is 0. At the top, ball is at the rest. This ball at the top is what? At the rest. Here is at rest. U is 0. When strike, after striking, their velocity becomes what? 0. Final. Initial is again U. Yeah, I consider U1. Yeah, U2. This is what? Again, velocity is there, but at the top, velocity of the ball becomes what? 0.5 meter per. Velocity becomes what? 0. Again, for the downward direction, we are applying v square is equal to u square plus 2s. This is 0. Sorry, this is the v before strike. This is what? V. Initial is 0. 0 plus 2. Here is acceleration. Acceleration is equal to g. It has value 9.8 or 10 meter per second square. So 2 into 9.8 into 1 meter. This v is equal to under root of 19.6 meter per second. Now for the upward direction, again we apply v square is equal to u square plus 2as. This is equal to 0. u2 square plus 2 into 9.8 into 0.5. So there is value of u. u2 becomes how much? Under root of 9.8. So diagram, we think about it, then velocity becomes clear, and there is change in momentum. Change in momentum is mv minus mu. Again, mv is how much? V was here. Certain velocity needs to strike. After striking, velocity becomes 0. But before strike, there is velocity under root of 19.6. So mass is how much? Mass is common here. I am writing here mass taking common, and this mass is basically 50 gram upon 1000. Velocity is here under root 19.6 and this is in opposite direction. So minus or minus. This is MB. I am writing here minus MU. This becomes what? Plus 9.8. Minus into minus becomes what? Plus here. This is how much? One upon 20. This value is almost 4.4. This value is plus 3 plus 1, 3.1. This is 5 and 7.5 upon 20. This is the value of what? Change in momentum. You know, impulse is equal to what? Impulse is equal to average force into time. And impulse is what? Change in momentum. You can say delta P or dP. So J is how much here? Change in momentum is how much? This is J, and this is 7.5 upon 20 is equal to average force, and time is here 0.1 second. So you can find the result of the average force. So average force is here how much? 7.5 upon 20 upon 0.1. This 0.1 and 0.1 goes house here. You can calculate easily. 15 upon 4. This is equal to what? 3.33. Zero something like that. Now other application is here. A body of mass 2 kg moving with initial velocity 5 meter per second in the same direction. Force act for the time 4 seconds. Shown in figure or graph. Find final velocity of the body. One graph or figure is given here in the question. We have to find out the actual value of the final velocity. There is in the x-axis time in second. There is force in Newton. There is 1 Newton. There is 2 Newton. There is 3 Newton. There is 4 Newton. Like that. There is time 1 second, 2 second, 3 second, 4 second, 5 second. Like that. Now, a body goes this is 1.5 second time. There is force 3 Newton up to the time 2.5 second. There is no force, you can say. Yeah, force 3 Newton is constant. Again, motion takes place. Up to 3 seconds. Then again, at 3 Newton force, there is constant condition up to this. Two Newton and 2 Newton constant. You know, force into time, it gives the area. So impulse you can find by the force into time or area graph. Area of the graph. Area of the graph. So there is what? Triangle. This is parallelogram. This is also, you can say, this is what? Trapezium. So I am writing area of triangle, area of parallel, area of trapezium, area of again parallel part. So this is half into base is 1.5, height is 3 Newton plus this is 1 second, this is 1, this is 3. So 3 into 1 plus trapezium. This is sum of parallel side and the distance. Parallel sides are 3 plus 0.5. Sum of parallel 3 plus 2. 3 plus 2. And this is 0.5. Again, last part 2 into 1. This is equal to how much? 7.5 upon 2 plus 3 plus 5 into 0.5 plus 2. This is equal to 3.25 plus this is equal to 2.5 plus 2. So impulse is here how much? Impulse is here 2, 2, 4, 3, 7, 3, 10. 10 plus 7, 5. This is the impulse. Newton second. You calculate itself. What will be the error? You can see that. Now this is equal to what? Impulse is what? Basically change in momentum. M into delta V is equal to what? G. So what is the value of delta V? Impulse is changing momentum. So I found it here delta V is equal to J is how much? 10.75 upon mass. Mass is 2 kg. So this is equal to 5 into 6 into 7. The total velocity, final velocity, you know, initial is how much? U plus V, या delta V. U is 5. There is 5.67. This is the actual value of the final velocity. So these are the applications. In the next class, we study about the tension. And tension is basically a force. You can say This is the reaction force. When action takes place in the any body, reaction also takes place. That is called for tension. So tension is part of each molecule, each atom of the body. Thank you very much.